In this video, we will be talking about partial derivatives. So let's say we have the function with two inputs, x and y, and our function is 3x squared y, and we want to find the partial derivative in respect to x. We could denote this as del f over del x. And to find the partial derivative in respect to x, you want to treat the y as a constant. So the derivative of 3x squared is simply 6x times y. And this will be your final answer. And now let's say you want to find the derivative in respect to y. So we have del f over del y, which is equal to, and now to find the partial derivative in respect to y, you want to treat the x as a constant. So the derivative for y is simply 1. So we have 3x squared times 1, which is equal to 3x squared. And this is our partial derivative in respect to y. In our next example, we have this function, and let's find the partial derivative in respect to x. So let's write del f over del x. And another way to denote a partial derivative in respect to x that you may see is an f with a little x. And this just means the partial derivative in respect to x as well. So let's find the partial derivative. So to find the partial derivative of x, remember to treat the y's as constant. So now let's find the partial derivative in respect to x. So for our first term, we have tan x times y squared plus, and now for our second term, we have 3x squared times y. And this would be our final answer. And now let's find the derivative in respect to y, the partial derivative in respect to y. So when you want to find the partial derivative in respect to y, remember to treat the x as a constant. So the derivative of y squared for our first term will be 2y. So we have 5x squared times 2y plus x squared. Remember just to treat the x as a constant, and the derivative of y here will be 1. And this simplifies to 10x squared y plus x squared, which is our final answer. In our next example, we have x squared times e to the y. So our partial derivative in respect to x would be simply, so remember to find the derivative of x, you want to treat the y as a constant. So the derivative of x squared will be 2x, and you simply just carry over the e to the y because the e to the y has an x term. And to find the partial derivative of y, you want to treat the x as a constant, and the partial derivative of e to the y would simply be e to the y. So our answer would be x squared times e to the y. And this will be our final answer. In our next example, our function has three inputs, which are x, y, and z. So let's find the partial derivative in respect to x. So for our first term, we have x squared, which gives us 2x times yz, plus our second term, we have x, which means the derivative is simply 1. So we have 4z squared, plus our third term, the derivative of y cubed in respect to x is simply 0. So that gives us this as our final answer for the partial derivative in respect to x. So now let's find the partial derivative in respect to y. So for our first term, the derivative of y will simply be 0. So we have x squared times z plus the derivative of the second term, since it has no y variables, it means the derivative of that would be 0. And finally, for our last term, the derivative of y cubed will be 3y squared. And if we get rid of the 0, our final answer would be x squared times z plus 3y squared. And finally, let's find the partial derivative in respect to z. So for our first term, the derivative of z would be simply 1. So we have x squared times y plus, for our second term, the derivative of z squared will be simply 2z. So we have 4x times 2z plus the derivative of y cubed in respect to z is simply 0. So let's simplify everything. So we have x squared times y plus 8xz. In our next example, we have the derivative of ln x plus y. So let's find the derivative in respect to x first. So we have to apply the natural logarithm formula. So we have 1 over x plus y times the derivative of the inner function in respect to x. So the derivative of x in respect to x is equal to 1, and the derivative of y in respect to x is equal to 0. So that gives us 1 over x plus y. And let's find the derivative in respect to y. So we have 1 over x plus y times the derivative of the inner function in respect to y. So the derivative of x in respect to y will be 0, plus the derivative of y in respect to y will be 1. So that gives us 1 over x plus y as our final answer.